we're at 8-2. We're talking about scatter plots. Hopefully none of you are thinking, Mr. A, your life must be boring if you get excited about scatter plots. Well, I'm not, I would say no comment, but I enjoy it. I actually got to do a lot of work with data, which is what we're going to talk about. And I always want to figure this out. Here's a question I would have, let's say for my 7th grade. Does the amount of time you spend doing your homework affect your grade? Like, does that really affect? And how I would do that is I'd ask, okay, Mandy, how many minutes did you spend? And then I look at her grade. Josh, and then Cole, and I'd ask every one of you, and I'd put it on a table, and then I'd graph that info. And then if I really wanted to get accurate, I'm going to ask the other class. If I really want to get more accurate, I go to other 7th grade classes, and I start getting what I call a scatter plot. But wouldn't it be nice to be able to say this to you guys at the end of all my research? I could say this. When you spend 25 minutes or more on your homework, your grade tends to be 80% or higher. Wouldn't that be nice to tell you? Because then you would just say, all right, I'm going to spend 25 minutes to get at least an 80, and then you can go more with that. But sometimes the data that I get will not show me that. After all that research, it doesn't tell me that. So how do we know it does tell me that? How do we know it doesn't tell me that? Scatter plots are going to help us to answer those questions. So what is a scatter plot? Okay, if you've never heard of the term scatter plot or seen a scatter plot, I'm thankful that this book has many scatter plots. Look at pages 380 to 381. Do you guys see all those graphs with all those little dots on them? Guess what those are called? Scatter plots. Okay, have you guys seen them before?
Yes.
Okay, if not, now you have. So now it's like, okay, kind of see what they are, not really sure. But what is a scatter plot? What is that graph with all those points on it? And the book is a good little definition that we're going to use. A scatter plot is a graph. So it's a type of graph. We have many graphs that we use. A graph that shows the general relationship and I'm going to underline general because that actually means a lot. The general relationship between two sets of data. Okay, so it is a graph, and you're like, okay, I get that part. And it shows the general relationship between two pieces of data, two pieces of info. One of the pieces of info that I'm concerned about with my sons, okay, like my son Titus he's going to be, it's going to be 11 months. By the way, this is what he's doing now. He sits down, and then he gets to some ledge, and then he picks himself up and just stands there. He loves doing that. He laughs, and he just smacks the table that he's on. Okay, that's his thing. But it's kind of hard to imagine from a baby when he was just like, my sister just had a baby, and her baby is like, it's almost like they don't know that they're there. They're kind of just like there. To now seeing 11 months later, they want to walk around. Like he wants to start walking around. But one thing I notice and I want to notice when I go to the doctor is that I want my son Titus to get heavier as the months go by. Why do you think I want that? He's growing. I want him to grow, right? Do you think it's good for kids to grow? Babies to grow? I think that's good. Even for teens and adolescents, it's good if you keep growing. By the way, some of you, don't worry. You will keep growing. Okay. So I want to see that, and I actually see in the doctor's offices, when I look at their screen, I see these scatter plots that have been collaborated, and now they have these lines that can tell me, where should my son be? He should be over here on this scatter plot. And so you're like, that's good or bad based on where he's at. What I want you to do is this. I want you to draw me an L, which is actually the part of a coordinate plane. Do you guys remember the quadrants? Do you guys remember first quadrant, second quadrant, third quadrant, fourth quadrant? Okay, if you don't, here it is. If this is my coordinate plane, like we looked at last lesson, this is the first quadrant. Second quadrant, third quadrant, fourth quadrant. Does that kind of make sense? Okay, when we look at scatter plots, we're normally looking at the first quadrant, okay? And this is what I want you to do. I want you to have a little bit of fun with this. Don't go too overboard. I want you to just put some dots on that first quadrant. Just scatter them around. Don't hurt yourself, by the way, doing that. Isn't that fun? Okay, go ahead and do that. Some of yours will look like mine. Some of yours will be more scattered, more compact. Doesn't matter. You do your thing. That's fine. Just don't poke a hole through your paper or break your pencil in the process. There's no point in doing that. But get your scatter plot going. And I'm going to do this because I'm guessing we did different things. Some of you did the same, close to it maybe, close to what I have, some way off. We're going to look at this to see what kind of scatter plot you have compared to mine and to each other. So that's your scatter plot. And then you have an x-axis and you have a y-axis. Does that sound familiar? I hope so. Okay, now what I want you to do is I want you to pick one point on that scatter plot. Just pick one point and box it in. So I'll go with this guy right here. Box it in. All right. So you get that point, whatever it is, it doesn't matter which one. It could be top, below, left, right. I want you to give me, what are the coordinates of your point? You're like, what? How are we supposed to do that? This is what I know. I know that the coordinates are in the form of an ordered pair, right? You have your x value, you have your comma, y value. But do I know what this x value is right here? Nope. It's unknown. You know what? It's a variable. I'm going to call it x, right? Isn't it x? You can call it z. Just make sure you put it in this order in just a moment. Do I know what this little tick mark is? Nope. But I know it's going to be y. I know it's some value. It's probably going to be, well, it is the y value, but you can call it something else. Now, can somebody give me the ordered pair? What's the ordered pair there? Yes, ma'am. Yep, it's x, y. That's your ordered pair. Like, okay, what does that mean? It actually means a lot. And if I think of it like this, don't do this. Don't count them up. But each one of these points has a distinct ordered pair, right? This one have one, this one, all these have distinct ordered pairs. How many do you have on your paper? Can you estimate? Just, someone counted in the last class. I'm like, why'd you do that? Don't do that. You can count. Some of you did 10, some of you did 50, some of you did 20. And some of you are counting. Just estimate.
17.
Okay, 17, 15. Okay, let me ask you this. It's a general question. The more data you have, the better information you can get from it. Or the less data you have, the better information you'll get. What do you think? More data or less data? Which one's better? More, right? So if you had a lot of dots, you have a better representation of what's going on. Okay? So here we have our scatter plot. And again, we're all different, but we're going to look at ours individually at the end to see what kind of relationship it is. So we're going to look at the next part, relationships. Not those kind. Not saying anything, just not those kind. Okay, relationships. We have 3 of them on the scatter plots. The first type is called a positive relationship. And positive means good, right? What do you think? Does positive necessarily mean good? No. Actually, I can think of many examples where, it could mean in a doctor's office it could be good, but even in a doctor's office it could be this. The more cancerous cells you have, the more of a problem it is, right? And that's not a good thing. But it could be the older you are, the bigger you are, the more weight you have. That's a good thing. So it can mean both. All right, what I want you to do is get your scatter plot going. And I want you to give me a similar type of scatter plot as I will put up here. What do those points, as you go more to the right, tend to be doing? They tend to go up. So the more you get higher on the x-axis, the higher you get on the y-axis. Does that make sense? Or you could say it, the lower you get on the x-axis, the lower you get on the y-axis. Does that make sense? That's a positive relationship. Okay, and I'm going to give you one example so you can kind of think of, we're going to call it age is your x-axis and weight is your y-axis. So can someone describe what I'm showing here on this scatter plot? What do I mean by age and weight? What is that? Huh? Okay, Davis?
The older you get, the more weight.
The more weight you put on. Oh, man. Is that good for my son? My sons? The older they get, the heavier they are? I think it's very good. It's still good for you guys because you still are growing. This is a good thing. And whether it's a good or a bad thing doesn't make it positive, but you just know the older you get, the more you weigh. Until you get to a certain point, right? Shouldn't it kind of level off a bit? Possibly, maybe? Okay. B, there's a second type of relationship. What do you think it is? Negative. And you could give me another scatter plot. Now, on the positive side, the more you got up on the x-axis, the more you got up on the y-axis. So what do you think the negative version is?
Off goes down.
Yeah, as you go more to the right, what happens to those points? They tend to go down. Good. You guys got the idea? Okay, can someone give me an example of two factors, two things in life that when one goes up, the other one goes down? So I'm going to see who can give me something that's so yeah. I just want to see your examples here. All right, Chelsea. Give me two things: a seesaw and what else? I got to get another thing. I think I know what you're saying. Like when one person goes down and when the other one goes up. But I'm talking about like weight and height. You know, like factors, things that change in life. Yeah, seesaw. That's kind of a cool one. Okay, Sarah Harris.
This happens only sometimes, but like age and height. Because sometimes like people when they're older get shorter.
Yeah, if I started like at, let's say, 60, and then 60, 70, 80, 90, people do tend to shorten up. The space between their bones kind of shortens up. Well, that's an extreme case of it. Okay, give me another one. Good. So, give me an example. What do you mean by it? Okay, the age of a car. As it gets older, what happens to its price? Goes down. Good. Anyone else? Yep.
Sometimes it goes up.
It does eventually, like an antique, right? After a few years, and it went down. And then after a while, you know what? People wanted it, and it started going up. So, yeah, it does change. But give me another one.
You eat a lollipop, but then you finish it. The age of a lollipop.
Okay. Yeah, the longer a lollipop's in your mouth, the less of a lollipop you have. That is true. Last one. Sorry, say that again. Oh, no. Not fidget spinners, guys. Those are going to last forever.
No, they aren't. They're already dead.
Okay. The longer a fidget spinner is out, the less sales you'll get. Good. You guys are doing really well. I like the car. It's the age of car. Yeah, the lollipop's good too. Fidget spinner, like those. And price. Now, this is what I want you to notice because remember my definition of scatter plots, I said the general relationship. I didn't say every single car that gets old will go down in price. I didn't say that, and neither is this saying that. In fact, as this is going up on the x-axis, you notice most points are going down. But look at this point right here. Isn't it still kind of up there compared to this guy down here? So I'll put another point there because I kind of covered it. Aren't they about the same age? And one is a lot more expensive, more pricey than the other? It just depends. Sorry?
That one's a Buick and that one's a Mustang.
Yeah, exactly. It could be a different make, a different model, whatever it is. It tends to go down, but that doesn't mean every single vehicle that is old will go down. Doesn't mean that. Okay, And then there's a third type.
Called a no relationship.
Yeah, no relationship. No relationship. And we had a little bit of fun in the other class, but I'm going to kind of keep it contained here. By the way, my graphs keep getting smaller, but the more I write, the smaller my writing gets. I don't know. But anyway, the no relationship would be this. This is what I've seen. The older you are in pre-algebra affects your grades. What do you think? The age of a person in algebra affects their grades. What do you think? What do you think it might be? You think you get better or you get worse as you get older? Worse? Worse?
Depends on how much you teach.
Yeah, so see what we're doing here? Cole, you want to add something?
The older you get, the harder it gets. So as you're getting smarter, it's also getting harder. So
It's kind of even, okay? Yeah? No. I've seen you draw on your paper. I'm scared of my interactive panel. Oh, okay. Anyway, I would say this. A younger student might do really well, but I've seen a lot of students who are just about the age that you're supposed to be, what they say supposed to be. You know what I'm going to see when I put all the data up there? Now I'm going to get some lines up there. No, sorry. They're just dots. I'm actually going to see that it's kind of scattered and there's no relationship. And I've seen it in my own experience. I've had young students who do really well and young students who don't do very well. I have older students who do really well and those who don't do very well. There's no relationship. Another one would be what? Give me another two-factor thing that don't have effect on each other. Yeah. Yeah, so give me, price of food and maybe age of the food. Wait, what?
Yeah.
So age of the food.
Mr. Hubbard has expired Jolly.
Oh my. Yeah, that affects the quality of the Jolly Rancher. Okay, yep. Sales on water bottles, yeah. And you have to give me another thing. Like the sales of water bottles and the month of the year may have an effect, but probably doesn't. I don't know. I'd have to do research. Here's one that affects us right now. The color of your hair and the grade in algebra or pre-algebra. Do they have an effect on each other?
Yes.
Oh, look at that. And you know what's kind of interesting? I hear a lot of people say, yeah, there's a certain type that we kind of bring up, and we're like, what about, okay, and even in this class, it's not true. So I haven't ever seen that actually happen, but the color of your hair, whether it's dyed or not, natural or whatever, and your test scores, they have no relationship. Some brown-haired people do really well, and some do not. Some blondes do excellently, and some do not.
No, it's his test.
It doesn't look like it's just test.
That's okay. I think you'll make it. Anyway, if you guys are understanding this, because here are your problems on your homework. This is what they're going to do. First problems are going to be this. They're going to give you a scatter plot with no units, and they're going to ask, is this a positive relationship, negative, or no relationship? You should be able to look at that. And then they're also going to give you problems where they give you two factors. They're going to say, test scores and color of hair. Do they have a positive relationship, negative relationship, or no relationship? You have to be able to answer that. And then one or two problems are going to be, they're going to give you a scatter plot with the units, and now you have to answer some questions about that scatter plot. So let's go ahead and get those right now, and I'll let you off on your homework. On page 381, let's see how this works out. Okay, 381, number 5. Don't call out the answer. Just answer the question, which is found above. Number 5, don't call it out. Number 5, is it positive, negative, or no relationship? Peter, if you keep talking, I'm going to keep you during break. Okay, Chelsea. Oh, do you have an answer? Okay, on number 5, which one is it? It's negative. It tends to go down. Does that mean that every point follows a straight line down? Nope, but it tends to go down. 6. Don't tell it out loud, please. Hopefully you can do this pretty quickly. Nick? No relation. Yeah, because it kind of looks like it's going down, but some look like they're going up. No relationship. None. And then 7. Sarah.
Positive.
Positive, because they tend to go up. Okay. Now, let me ask you this question here. We also have, and this is not part of the lesson, we have strength of positive relationships and strength of negative relationships. Looking at numbers 5 and 7, which one do you think is a stronger relationship? Which one has a stronger relationship and why? So what I'm looking for is number 5. Is it a stronger negative relationship than number 7 is a stronger positive relationship? And you're like, huh? Well, maybe some of you can help me out here. Josh?
Is number 5 a stronger relationship?
Why?
The dots look a little closer.
They look a little bit closer. That's what tells you the strength. If they are closer together, they are stronger in positive or negative relationships. And we can debate about it, but that's how you determine it. Okay, number 8. Determine whether a scatter plot of the data for the following might show a positive, negative, or no relationship. And then we'll talk about the answer. So number 8, your weight and the month of birth. So your weight and your month of birth. What kind of relationship does that have? And we're thinking about us. Someone brought up, what if it's a baby? Yeah, it has more relationship, but think about all people. What does it tend to do? Cole? No relationship. Your month of birth has really nothing to do with your weight, other than like a baby, right?
None.
Baby. Yeah, you're right, none, or no relationship. Number 9. Man, people were debating me on this one, but remember the definition of scatter plots, general relationship. Your playing time and the points you score. You can think of really many sports where you can score points on your own. Basketball is a good one. Soccer can be a good one. Hockey, lacrosse, volleyball. They award points differently, don't they? They give you like kills and so like no. I don't know. I'm sorry.
You get a point every time.
Oh, that's right. But like they give you like stats for how many kills you have, how many blocks you have, like for you. I've seen it with college. Well, that's what I mean. Like, but in baseball, they also give me a batting average. They don't really do that in Little League, but they can. Okay. Okay, but what do you have here? Playing time and points scored, Peter.
None. Because usually you can play for like a long time and not score a lot of points.
Okay, and that's possible, definitely possible. Okay, so this is number 9. Another answer here. Yes, Sarah?
Positive. Let's say you had like 2 minutes, you probably didn't get as much as you could in like 12 minutes or an hour. Not really that
Yeah, and this is what we mean by general relationship. If I were to plot this is what I would get. Now, Peter, you brought up someone who plays a long time and doesn't have any points. Does that happen?
Yeah.
Of course it does. Are there some people who play not that long, score a lot? But what do people tend to do? What's the general?
Put in the people that score the most.
Yeah, the more you play, the more you score. It's a general thing. Not that, Mr. A, I knew this one guy, played all season long, played half the game all season long, never scored a point. Yeah, he would go right here. But what do people tend to do? The more you play, the more you score. That's what you tend to do, general. Mr. A also knows someone who didn't ever play, and he scored a lot. And yeah, I knew another guy. Great. But what do they tend to do? They tend to go up. Okay, so we would say what kind of relationship? Positive. Okay, number 10. We'll end off on this one. Track and field. The scatter plot at the right compares the winning time to the year of the race of the women's Olympic 100-meter dash. And what kind of relationship are you noticing with that 100-meter dash times? And let's see if you guys can pick it out. It's a little trickier, but I don't think too bad.
Negative.
Sarah?
Negative.
Yeah, negative. But you're like, wait, isn't negative a bad thing? Look at that chart. Look at that info. Is the time being decreased a negative thing for the 100-meter dash? What do you think? That means they're getting faster, by the way. That means they're ending sooner. So isn't that a good thing? They're getting quicker? Okay, so you're looking at that scatter plot, and you're going to answer some questions which could be unique to that scatter plot itself, okay? So your homework tonight is 11 to 22.
Odd or 20 standard is not an odd number.
11 to 22, and I'm going to cut out some problems. I cut out the extras, and that's on page 382. And by the way, number 14 has A, B, C, and D, so that's worth 4 points. So don't skip 14 like, I don't want to do it. That's 4 points off if you skip it.
Wait, and 14? So it's 11
yeah, it's 11 through 22.
Oh,
yeah,
geez,
and 14.
Sorry, I'm so used to odd.
That's okay. Yeah, so it's all of them, 11 all the way to 22. Answer all of them. Don't skip any, because that will really...
We just write like no relationship.
Yep, no relationship, positive, negative, whatever it is. And then on 14, just be careful what they're asking you for. And 15 to 22, just think generally, when this thing goes up, the other one goes up, or does it go down? And that determines whether it's a positive, negative, or no relationship. But Mr. A, I had this one friend who, okay, he would be that one dot there. And then think of all the other dots that form that scatter plot. All right, thank you guys. You did well.